All right, this is your SOHCAHTOA review and refresher. So, first of all, we're going to start off with the Pythagorean theorem. Remember the Pythagorean theorem, we're talking about a right triangle. The legs are the two sides that make the right angle. The hypotenuse is the side across from the right angle. The hypotenuse is also always the longest. We call the hypotenuse C, and the legs are A and B, and the Pythagorean theorem says A squared plus B squared equals C squared. The square of the sum of the squares of the two legs equals the square of the hypotenuse is the mathy way to say that. So we are going to find the missing side. It says do not round, but for this second one we are going to round. So for this first one, I see that across from my right angle, that's my hypotenuse, so I'll call that C. The other two are A and B, and it doesn't matter which one's which. So I take A squared plus B squared equals C squared. Well, A is 5 squared, B is 12 squared equals C is X squared. Now, order of operations, I square these numbers. So I get 25 plus 144 equals X squared. Add those two numbers together, I get 169 equals X squared. And undo that square with a square root. Now, normally we get a positive and a negative when we undo a square, but since we're talking sides of a triangle, we only get the positive. So X equals 13. I'd always label it, if possible, in yards. For the second one, we'll do the same thing. So across from the right angle is our hypotenuse, so that's C. The other two are A and B, and it does not matter which one's which. So then we plug in A squared, 8.6 squared, plus B squared, 15.1 squared, equals C squared, which is X squared. Now I'm going to need a calculator here, but 8.6 squared is 73.96, plus 15.1 squared is 228.01. Add those two together, I get 301.97, and then we'll square root it to get X is approximately 17.377 meters. All right, now we're going to not round. So I start off, I identify what my hypotenuse is. Across from the right angle, there's C. A and B doesn't make a difference. You can flip-flop those two. So A squared is X squared. B squared is 11 squared. C squared, the square root of 257 squared. Square those two numbers, X squared plus 121 equals, the nice thing about a square root and a square is that they cancel, leaving me just 257. Subtract that 121 over, and I get that X squared equals 136. Square root both sides. Now the square root of 136 is not a whole number, so this is where the do not round part comes in. We're going to simplify that square root. And 4 goes into 136. It's 4 times 34. 34 doesn't have a perfect square that goes into it. Square root of 4 is 2. Square root of 34 stays. Label it kilometers, and we're done. For this one, identify the hypotenuse. C is 13 in this case. A and B doesn't make a difference. We can flip-flop them. So I take 7 squared plus X squared equals 13 squared. 7 squared is 49 plus X squared equals 169. Subtract my 49 over. I get X squared equals 120. Take the square root. Can I break down the square root of 120? Yes, I can. It is 4 times 30, and 30 does not break down any further. So my X value is 2 square root 30, and make sure to label it miles. All right, so that brings us to the actual trig functions. And in the trig functions, we label our sides of the triangle a tiny bit differently. We'll always have the right angle, and across from the right angle is still called the hypotenuse. I shorten it down to HYP. All right. Then it's going to depend on which angle we're talking about. So let's say I'm talking about this one. This symbol right here is theta. It's like a 0 with an extra little loop. Across from the angle that I'm talking about, we call the opposite side. And for my shorter version, I put OPP. And then the side that touches the angle that isn't the hypotenuse, we call that the adjacent side, or ADJ when I'm shortening things up. So realize if I had been talking about this angle up here, my opposite and my adjacent would have flip-flopped. All right, but the hypotenuse always across from the right angle. So you may have heard of SOHCAHTOA before. SOHCAHTOA stands for sine, cosine, and tangent. Sine has an O and an H with it. O for opposite, H for hypotenuse. So that means the sine of my angle is the length of the opposite side over the length of the hypotenuse. Cosine, ka, has A and H. A for adjacent, H for hypotenuse. The cosine of our angle x is adjacent over hypotenuse. And then TOA, T-O-A, T for tangent of x, equals O for opposite, A for adjacent, opposite over adjacent. Now something very important here. Notice that sine, cosine, tangent, all are written with something next to them. If I just write this, that means nothing. You have to have the sign of an angle. You could actually put the measure in there. You could put an x, a theta, whatever. You have to have something there. There's a great SOHCAHTOA song that we will watch in class that I very, very much recommend looking up. So let's find the value of each trig ratio for this circled angle. So I take my angle and I first identify the sides. Across from the right angle is my hypotenuse. Across from my circled angle is my opposite, and that third side is my adjacent. So the sine of my angle, well, I know this angle is named A, so I can say the sine of A is equal to opposite over hypotenuse. So I'll take 32 over 40. But we also want to simplify these if we can. I can divide the numerator and denominator both by 8, leaving me 4/5. And that's how we'll leave it. The cosine of angle A, actually, if you wanted to write it out more neatly, it'd be the sine of A equals 4/5 like that. Cosine is adjacent over hypotenuse, so 24 over 40. But I can again divide those by 8. So I get 3 over 5. So if I write it a little more neatly, the cosine of A is 3 over 5. And tangent of angle A, tangent is opposite over adjacent, so 32 over 24. Divide both of those by 8. Leaves me with 4 over 3. So the tangent of angle A is 4 over 3. And there are my answers. So let's try the same thing for this triangle. We're looking at angle C this time. Across from my right angle, the biggest side, is my hypotenuse. Across from the angle I care about is my opposite. Third side's always my adjacent. So the sine of angle C is opposite over hypotenuse, which is 14 over 50. I can divide those both by 2, leaving me with 7 over 25. So sine of angle C equals 7 over 25. The cosine of angle C is adjacent over hypotenuse, so it's 48 over 50. Divide those each by 2. I get 24 over 25. So the cosine of angle C equals 24 over 25. And the tangent of angle C is opposite over adjacent, so 14 over 48. Divide those both by 2. We get 7 over 24. So the tangent of angle C equals 7 over 24. This whole thing is my answer. Yes, you have to label sine of C, cosine of C, tangent of C. You cannot just write the 3 fractions because then I don't know what they mean. So now we are going to solve for the length of side BC. So the first thing I like to do is label that as x. B to C, that's what I'm looking for. you'll notice that angle A has a measure in it. So let's base everything off of that angle. Across from the right angle is my hypotenuse. Across from that angle is my opposite. Third side is my adjacent. If it helps, write SOHCAHTOA. O has an X by it. H has a number by it. O and H, we're using sine. So the sine of my angle, I have a number now. I can type or write in the sine of 54 degrees equals opposite, which is X, over hypotenuse, which is 18. Now the sine of 54 degrees is just a number. To solve for X, I multiply the 18 over to the other side. And now I type this in my calculator. Into my calculator, I'm going to type 18 times the sine of 54 degrees. There's a couple important things you have to do to get this answer. So we take our calculator. The first thing is to make sure that your calculator is in degrees mode. So right here, you have a mode key. Click that. The third thing down says radian or degree. Right now, my radian is blackened, which means I'm in radian mode. That's a different way to measure angles, and that's not what I want. Use the over arrow to degree, press enter. Now I'm in degree mode. All right, now I type in my problem. 18 times, you'll notice you have sine, cosine, and tangent keys. We just press sine. And what was it again? 54 degrees, so 54. Close my parentheses, press equals. You'll notice that it's not a nice round number usually. That's okay. We'll go 3 decimal places, 14.562. And always double check. Our side was labeled inches, so this side should also be in inches. There we go. Now we're going to solve for this x. Well, we've got an angle labeled. So across from the right angle is my hypotenuse. Across from that angle is the opposite. Third side is the adjacent. Write out SOHCAHTOA. My opposite has a number, so it means I'm not using cosine. My adjacent has the variable, so I'm not using sine. I'm using tangent. So the tangent of my angle, which is 32 degrees, equals opposite over adjacent. So 11 over x. This one's a little trickier to solve. We have to get the x to the other side, so I multiply my x over. So I have x times the tangent of 32 degrees equals 11. To get x alone, we just divide by the tangent of 32 degrees. And now x is alone, and I can type that in my calculator. For this one, we just do what it says. 11 divided by tangent 32. I already know I'm in degree mode, so 17.604. We did not have any labels, so there's my answer. Let's solve for x. Start by labeling my sides. Across from my right angle is always my hypotenuse. Across from the labeled angle is my opposite. Third side is my adjacent. If I think of SOHCAHTOA, my A and my H have something by them, which means I'm using cosine. So the cosine of my angle, 18 degrees, equals adjacent, which is x, over hypotenuse, which is 18. To get the x alone, we just multiply the 18 over. Notice that the 18 does not combine with the angle in here. It's 18 times whatever the cosine of 18 is. If I took my calculator and just said cosine of 18, I get 0.9510 blah, blah, blah. Then I'm multiplying that by 18. So that's how I'm getting my answer. X equals 17.119. I've been typing it in up until now as just 18 times the cosine of 18, which absolutely works as well. All right, to find x in this one, let's look at the sides we have. Across from our right angle is always the hypotenuse. Across from my labeled angle is my opposite. Third side is always my adjacent. Look at SOHCAHTOA. I have a label by O and A, so I'm using tangent. So the tangent of 17 degrees equals opposite, which is 19, over x, which is my adjacent. Again, this is a two-step problem. I multiply the x over, and then I divide both sides by the tangent of 17 degrees. Type that in my calculator. 19 divided by the tangent of 17 is 62.146. There we go. To solve this one for x, label my sides. Across from the right angle is my hypotenuse. Across from my labeled angle is my opposite. Third side is my adjacent. Think about SOHCAHTOA. Opposite and hypotenuse have labels, so I'm using sine. The sine of 59 degrees equals x over 12. Straightforward, I just multiply 12 to both sides. 12 times the sine of 59 degrees. The value of x is about 10.286. All right, for this one, start by labeling my sides. Across from the right angle is my hypotenuse. Across from my labeled angle is my opposite. And third side is my adjacent. My goodness. If I look at SOHCAHTOA, I have labels by the adjacent and the hypotenuse, which tells me cosine. So cosine of my angle, 58 degrees, equals adjacent, which is 15, over hypotenuse, which is x. Oh, look, we have a two-step problem. Anytime x is in the denominator, it's two steps. Multiply the x over. X times the cosine of 58 degrees equals 15. Divide both sides by the cosine of 58 degrees. And then I have x alone, and I can type it in my calculator. .306. Now, most of the time, our sine, cosine, and tangents of an angle are not nice numbers, which is why I never recommend plugging them into your calculator until the very last step, so that way you can make sure you didn't make a rounding error. Next up, we have trig inverses. Trig inverses are used when we're trying to find an angle. We're trying to undo the trig function. So if you're given the opposite and hypotenuse sides, you'll use sine inverse of x. If you're given adjacent and hypotenuse, you'll use cosine inverse. If you're given opposite and adjacent, you'll use tangent inverse of x. Notice that there's always something next to it. That's technically like inside of this function. It's like having something inside of an absolute value or inside of a logarithm. There's another notation that's actually more common as you get higher and higher in math. Inverse sine is often called arc sine of x. Inverse cosine is often called arc cosine of x. And inverse tangent is often called arc tangent of x. Sorry about my weird S there. That notation is more common, especially in calculus, because the little -1 can be misunderstood as an exponent rather than the inverse symbol. So we're going to find this angle. To find this angle, let's look at the sides we have. Across from the right angle is hypotenuse. Across from the labeled angle is opposite. Third side is adjacent. We're still going to look at SOHCAHTOA. My O and my A have labels. O and A are a TOA. So the tangent of my question mark equals 14 over 22. But I can't do anything with that. To undo tangent, I get my question mark alone. I take the inverse tangent of 14 over 22. Now I'm going to type that in my calculator. To type it in, show you some more buttons here. You'll hit second tangent. Notice that tangent -1 pops up. And then we'll type in 14 divided by 22. No need to simplify because there's our answer, 32.471 degrees. So our angle is 32.471 degrees. Don't forget the degrees symbol. It's an angle. It's measured in degrees. Label it degrees. All right, next up, label our sides. I have my hypotenuse, opposite, and adjacent. If I look at SOHCAHTOA, I have labels by A and H, which is cosine. Cosine of my angle equals 45 over 51. To undo cosine, we use inverse cosine, or you could call it the arc cosine of 45 over 51. Same exact thing. To type it in our calculator, though, we don't have a button that says arc cosine. We just have inverse cosine, 45 over 51. My angle is about 28.072 degrees. All right, to solve for this question mark, look at what we've got. Across from the right angle is my hypotenuse. Across from my question mark is opposite, third side's adjacent. I'm looking at SOHCAHTOA. O and H have labels. That is sine. The sine of my angle is 45 over 53. To undo sine, I use inverse sine or arc sine. Type that in my calculator. Second sine, 45 divided by 53. My angle is about 58.109 degrees. And now for this one. When I label my sides, across from the right angle is my hypotenuse. Across from my labeled angle is my opposite. Third side's adjacent. If I look at SOHCAHTOA, I have enough information for any of them. I can pick. So I could say that the sine of my angle is 42 over 70, or the cosine of my angle is 56 over 70, or I could say that the tangent of my angle is 42 over 56. These will all give me the same answer, believe it or not. So I could do the inverse sine of 42 over 70. I could do the inverse cosine of 56 over 70, or I could do the inverse tangent of 42 over 56. I'll just show you that these do all give you the same answer. So inverse sine of 42 over 70, inverse cosine of 56 over 70, inverse tangent of 42 over 56. All of them tell me the same thing. My question mark is 36.87 degrees. And finally, we're going to talk applications. Edith is trying to jump onto Miss Dupree's counter. She knows that the angle from where she is to the top of the counter is 65 degrees because she is a very smart cat, and that the counter is 3.6 feet tall. How far is Edith from the base of the counter? I always, always, always recommend drawing a picture. So we have little Edith, and we have a counter, right? We know the counter is 3.6 feet tall. We know that the angle from where she is to the top of the counter, so where she is to the top of the counter, is 65 degrees. I want to know how far she is from the base, so there's my x. All right, if I look at this, I notice that I have my opposite and adjacent, which means the tangent of my angle, 65 degrees, equals 3.6 divided by x. And now I solve. Multiply x to both sides. X times the tangent of 65 degrees equals 3.6. I'll divide by the tangent of 65 degrees. And Edith's distance to the counter. Be careful here. Make sure you're not using an inverse tangent, just regular tangent. 1.679 feet. That's how close Edith is to that base of the cabinet. Couple vocab words. Angle of elevation. The angle of elevation is the angle from the horizontal upward to an object. So if I'm looking straight out, the angle I have to tip my head up to see my object. Angle of depression is the angle from the horizontal downward to an object. This is one that people screw up a lot. From horizontal, the angle, you have to tip your head down. A lot of people try to put it here. That's not where it goes. It goes over here. So let's try an application problem. Mr. Priest spots her cat Stuart from the top of a vertical cliff that is 40 meters high. The angle of depression to Stuart, who is level with the base of the cliff, is 34 degrees. How far is Stuart from the base of the cliff? So I'm on a cliff. Here's me. And down here is Stuart on the ground level. My cliff is 40 meters high. My angle of depression is 34 degrees. So from straight out, the angle I tip my head down is 34 degrees. I want to know how far Stu is from the base of the cliff. There's X. I got my right angle. Now there are two options when you use angle of depression. You can think about the fact that this is going to be another 90-degree angle. So what plus 34 makes 90? Well, that's 56 degrees. Or you could use your knowledge about parallel lines cut by a transversal and know that this angle of elevation from Stuart to me is also 34 degrees. I like the 56 in this case because then I have my opposite and adjacent. I know the tangent of 56 degrees equals x over 40. Then I just multiply the 40 over. So 40 times the tangent of 56. Stuart is approximately 59.302 meters away from the base of the cliff. Entirely too far away. Dang it, Stuart. And one last application. A man flies a kite with a 100-foot string. The angle of elevation of the string is 52 degrees. How far off the ground is the kite? So when you fly a kite, it doesn't usually fly straight up in the air, right? You're usually holding it and it's trailing back here. So that's the string, 100 feet. I want to know how high off the ground it is. I know the angle of elevation, so from straight out, the angle the man has to tip his head up to see the top of the kite is 52 degrees. So here's my kite. All right. I have my opposite and my hypotenuse. We are using sine. The sine of 52 degrees is equal to x over 100. Multiply the 100 over. This kite is 78.801 feet above the ground. All right, so you're going to do a SOHCAHTOA refresher packet as some practice.